Hi, I'm Rachael COLLEY and I'm currently finishing my PhD in computer science as a member of the LILaC team at irit.
What motivated your choice of a career in computer science research?
I have always been interested in using theoretical techniques and applying them to social problems. This started in my undergraduate degree where I studied mathematics and philosophy. I focused on political philosophy and formal methods to prove theorems about systems. It was only in my master's degree where I was able to connect these passions. I was able to study collective decision-making from an algorithmic perspective. While working at Toulouse, I've continued in this study. I am fascinated by the intersection between these different disciplines, and having a career in academia allows me to explore how computer science can help us decide on what makes a good collective decision-making procedure. For example, are the voters able to strategically change the outcome? Will the voters affect one another's outcomes? And does it matter how we collect the voters' opinions?
In what context have you developed or are you developing your research?
My research field is called computational social choice. So we're interested in the computational aspects of collective decision-making. The first thing we have to decide is how voters should give their opinions. Is it by giving us their favorite candidate or ranking over the candidates? Also, do all agents need to give us the same kind of ballot? Next, we must decide on how the outcome will be returned to the community. This means we have to find a function to give an outcome. And can we justify why the outcome is good? Can we ensure that voters think that the rule is fair? Does it maximize the happiness of the voters? Or does it minimize how disappointed the voters are? Also, another thing we have to consider is, do we need a tie-breaking rule? Then there are practical computational questions to be answered, such as, how long will it take a computer to find a strategy? How hard is it for the voters to find a strategy to manipulate who's the winner? Finally, there's a question of purpose, as not every rule will be suitable for every situation.
What are you passionate about in your research area?
I'm particularly interested in balancing the benefits and drawbacks of direct and representative democracy. In direct democracy, every agent votes directly on every issue, for example, either for or against the issue. However, this can leave voters uncertain of how to vote in some cases, like the pink agent on the left-hand side image, who doesn't know how to vote on this issue and abstains from the vote. The usual alternative is representative democracy, where the most popular representative votes on behalf of all of the voters. This means that voters no longer have to be informed on every issue, as a representative will vote on their behalf. However, it does mean that some voters may feel underrepresented. Again, here we see the pink voter on the right-hand side image that wants the orange voter to represent them, yet the green voter votes on behalf of all of the agents. My main research area has been in liquid democracy, as it tries to balance the benefits and drawbacks of direct and representative democracy. In liquid democracy, voters are able to decide if they want to vote directly on the issues, either for or against it, or they can choose to delegate their vote to another voter. In our example here, we see that the pink voter delegates to the orange voter. Now the orange voter will decide how both of their votes will be determined. In our example, as the green voter votes for the issue, this means that the votes of the orange and pink voters are also for the issue. This model allows agents to choose when and how they should choose their representative, thus improving on both direct and representative democracy. However, problems can occur in this model. For example, here there's a cycle between two agents and we don't know how their vote should be determined. My research has been focusing on the theoretical and algorithmic problems raised by extending liquid democracy to more expressive and rational models, as well as finding possible solutions. We make liquid democracy more expressive by expanding the possible ballots of an agent. The image on the left-hand side of the slide shows multi-agent ranked delegations. In this model, agents can give more complex delegations. Here, the purple agent now wants their vote to be determined by the majority outcome of the other three agents. We also allow voters to give many ranked delegations. This means that if there's a problem determining their vote, then an alternative delegation can be used. Given this more complex model, we have many algorithmic questions of how to find votes for all the voters. I'm also interested in making delegations more rational. For example, if you're making many delegations to many different voters on different issues, in our example, the orange agent delegates their decision on the painting class to the blue voter and on the movie to the red voter. This could lead to irrational ballots. Here we see that the orange voter has chosen to attend all 3 activities when there's only time for 2. Our question here is, how do we regain consistent votes for all of the voters once the delegations have been resolved? I've learned a lot from my PhD, and I'm looking forward to a career in research. I'm able to learn about many different new topics, as well as being able to share my research with others.